Okay, welcome Algebra 2 students. We're going to go ahead and talk about section 1.3, which we're going to start with the idea of function notation. Now, function notation indicates that the equation and the graph represent a function. Now, a function is a relationship between the input x and the output y, such that for every number I put in for x, I'm only going to get one output for y, which means that if I get one in, I get one out, rather than putting one in and getting 4 out, or 2 out, or 3 out. So I should only get one, kind of like the way a vending machine is supposed to work. You put in your money, you get one thing out. You put in more money, you get another thing out. Not that you put in money, get nothing out, or you put in money and you get 3 things out. So that means that it's not functioning as a vending machine anymore. So when we know something's a function, what we do is we first start by writing our original equation with y by itself. So we solve for y, get y all on one side by itself, and then we replace y with our function notation. Now our usual function notation looks like f parentheses x. It's called f of x. Some people call it f at x, and that's okay too. And this just indicates that it's a function. Now, because we have multiple functions, we'll also go g of x, p of x, h of x, stuff like that. So what we're going to do is we're going to rewrite each equation in function notation. And so all we really do is, since the y is all by itself, I replace this with my function notation. So this is f of x equals 2, oh dear, I'm sorry, my computer's going really slow right now, 2x plus 4 minus 6. And so on the next one, we'd name it, and since I've already used f, I may go to g. So g of x equals x to the third minus 2x plus 9. So all I do is I replace the y with that function notation, and we should be good to go. So then we have h of x equals 2 square root 1 plus x minus 6. And that's our function notation. That's it. So now what we're going to go ahead and do is we're going to use our calculators to relate how the function notation, equation, and transformations relate to each other. To start, we're going to make sure our calculator graph is set up to be -10 to 10. So what we're going to do is we are going to go ahead and we're going to use the zoom button, which is right here on our calculator, and we're going to help set our graph to a standard graph, which is -10 to 10, -10 to 10. So I'm going to grab my graphing calculator, and I'm going to go ahead and I'm going to do zoom, and then we want to arrow down to zoom standard. And so this will give us a standard graph of -10 to 10. So -10 to 10, -10 to 10. And so then what we're going to go ahead and do, and so we use that zoom button, we're going to go ahead and we're going to hit the y equals button. So that y equals button is right here. And then what we're going to do is we're going to plug in the equation y equals the absolute value of x. Now to do the absolute value of x, sorry, I accidentally stepped on my mic cord. We're going to hit math button, which is right here. And then we're going to arrow over. So let me show you what that looks like. Calculator, there we go. So I'm going to hit y equals. Now I'm to where I can put in all the equations I want to graph. And I'm going to hit math. And I'm going to arrow over to number. And we're going to choose absolute value. And we're going to go ahead and plug in x. So this is the button I use for x right here that's red. And that'll plug in the x. And so if we want, we can go ahead and graph it. And we see our lovely graph of absolute value. And we see how that looks. So back to here, the buttons we use the math for absolute value. And we use this graph to graph it. And we used, this is where that x was. So these are kind of the key buttons we're using. Now what we're going to see is what happens when we transform it. So we're going to transform our function, which means that I'm going to go back to y equals. So I'm going to go back to y equals, maybe. y equals, and I'm going to arrow down, and what I want to do is see how this graph is y1. So what I want to do is I want to change y1. So what I have to do is put in y1 here. So if you have the new calculators, you can do alpha trace, and y1, you see how y1 selected right here? I can just hit enter and it'll put in y1. And I want to add 2 to that. Now what if your calculator doesn't do that? So I'm going to clear this. If your calculator doesn't do that, so if you have that TI-83, you have to go to this vars button, which stands for variables. We're going to arrow over to y variables, and there it's the function, and we're going to select y1. So you can still do it even if you don't have the newer calculators, but the newer calculators are a little bit easier. They have more shortcuts. And then I hit +2. So now we're going to see what happens when I take this graph and I add 2 to it. See how that blue graph has just now shifted up 2. So this is a vertical shift of 2. And so that's what we're talking about, what's going on right here, is that my graph changed by moving up 2. So the original one looked like this, the new one goes up 2. And what we did is we took that original function and I added 2 at the end, which means that my new graph really looks like y equals the absolute value of x plus 2. So I took that original one, I just added 2 on the end, and that moved it up 2. So my equation of the transformed graph is this, and that function notation was this. So we're going to look at more function notation and how it affects our graph. Okay, so now what we're going to do is we're going to try y1 minus 3. So I'm going to go back to my calculator, and I'm going to go to the y equals, and I'm going to come down. I'm going to do y1, oops, down, y1, and I want this to be a minus 3. So let's graph that and see what happens. Looks like it moved down 3, which is good because that's what I thought. If the plus moved it up 2, the minus 3 would move it down 3. And so that's exactly what happened. This went down 3, which means my equation now would be y equals the absolute value of x minus 3. And so the function notation is my original function, and then I put minus 3 at the end. And that original function was just that whole y equals the absolute value of x. Okay, so now we're going to get a little different. Now we're going to do y1 parentheses x minus 4. This means that in the x spot, I now want x minus 4. So I'm going to go back to my calculator and go to y equals. I'm going to come down, and here I'm going to do parentheses x minus 4. I want to see how that changes our graph. So we're going to hit graph. And that's weird because it shifted to the side, but it shifted to the right side even though we did a minus 4. So that's odd to me. So this went right 4 even though it's a minus. And that means my equation looks like y equals, and remember this goes in the x spot, so instead of absolute value of x, it's going to be absolute value of x minus 4. And in function notation, this would look like f, and then in the x spot, it's going to be x minus 4. And I'm trying to show you like how the graph looks, how the equation looks, how that function notation looks, so you understand how this all comes together. So now we're going to go ahead and try y1, and then in the parentheses, x plus 5. So the x plus 5 is going to go in there. So let's go back to our y equals. I'm thinking this one moved right. This one should move left. Let's see, x plus 5. Okay, and I'm going to hit graph. And it did, it went left 5. So it's almost like that when it's inside the parentheses, it goes opposite. So this one was left 5. So I'm going to put a little star right here. and kind of make a little note to myself that this was opposite. It's opposite of what I thought it would be. So what's my equation? Well, y equals absolute value x plus 5. What's the function notation? My function at x plus 5. Okay, so now we're going to go ahead and we're going to do negative y1. Negative y1. Let's see what happens here. So we're going to go to y equals. We're going to come down here. I'm going to clear this out. So if I have the shortcut, I do alpha trace. Oh, I don't want to do that yet. Clear. There we go. So I wanted negative. Now remember, negative we have to use down here. We cannot use the minus. We have to use the negative button. Now I'm going to do alpha trace. Ah, that didn't work. Go to. Sorry. Negative alpha trace. It didn't register that. y1. There we go. Negative y1. Now we're going to graph. Maybe we're going to graph. My board's being not sensitive. Okay, so it looks like it took this blue graph and it flipped it over that x-axis. So we flipped over the x-axis. Woo! Whoops, sorry about that. Flipped over x-axis. So that means that my equation, because this negative is on the outside of the y, that means that this is going to be y equals negative absolute value of x. Okay, so now let's see what happens if we do y1 parentheses negative x. So I'm changing the inside part. There we go. So y equals, arrow down. I'm going to clear that. I'm going to do alpha trace y parentheses negative, don't forget the negative, not minus, x. So let's graph that. It's the exact same graph. So if it's the exact same graph, that means that if the other one flipped over the x-axis, this one flipped over the y-axis. So remember how this point ends up here, this point ends up there, and so on and so forth. So it ends up just being the exact same graph, which it just flipped over the y-axis. So our equation now would be y equals the absolute value, and remember this gets put in the x spot, negative x. The function notation, oh, I forgot to do the function notation. So this is negative f of x. This one is f of negative x. Okay, so now we're going to go ahead and we're going to try y1, and we're going to insert 4x. Insert 4x. So let's go back to my calculator. So now we have y1. I'm going to arrow down. I want this to be 4x. So I'm thinking this is going to affect my x values because it's inside. It's inside with the x. So I'm thinking it's going to affect my x values. So I'm thinking it's going to be a horizontal stretch. Let's check. There's my original. Oh, it's not a stretch. It's actually a compression because this point has been pushed in. Oops. These points have all been pushed in. So this is a horizontal, but it's a compression. So let's take a look at go back here. So how did the graph change? Well, it was a horizontal compression. And remember, if it's a compression, I'm timesing by a fraction. So if this was a 4, my compression is going to be 1/4. So it was the opposite of what I thought it would do. The equation would be y equals the absolute value of 4x. And so now our function notation is f of 4x. So when the 4 is in the inside there, it kind of does that opposite. Kind of like up here. This was an opposite. It said minus, but it really moved it in the positive direction of right. This said plus, it moved it in the opposite direction of left. This looks like it's timesing by 4, but really it's dividing by 4, so it makes it, instead of a stretch, a compression. So I think on number 8, when I do the 1/4 x, it's going to be a horizontal stretch of 4. So let's double check. So y equals, now to do the fraction 1/4, if you have the new calculators, you can do alpha y equals and allow you to put in a fraction. So right here, that's my fraction option. I put that in there and it'll allow me to put in 1, arrow down to 4. I didn't want this 4 to still be there, so I'm going to delete. So now I get that 1/4 x. How do you get the fraction without it? If you have the 83, well, that's not as fun. So really what you're going to want to do is, here I'm going to clear it out. So I'm going to go vars, y vars. So I'm going to pull in that y1. And then I have to do parentheses. And then for the 1/4, I have to do another parentheses and do 1 divided by 4 and parentheses for my fraction. So now that's my 1/4. And now I have to have the 1/4 times x and then finish off that parentheses. So you may now understand why I recommend the 84s, the newer ones, especially colors, because I like graphing in the color. You can really see what's happening, versus the 83s. But again, that's just a preference. You can do it all still. So let's see. Boom! It stretched out. Yes, and it stretched out by 4 because this is an up 1 over 4. Up 1 over 4. Yep, so it is a horizontal stretch of 4. Kind of like being right, if you haven't noticed. So horizontal stretch of 4. So our equation would look like y equals absolute value 1/4 x, and then our function notation is f of 1/4 x. So we're starting to notice that stuff on the inside is going to have an opposite effect. Now let's go ahead and look over here. So remember in the beginning we had a +3, it moved it up to, +2, moved it up to, a -3, moved it down 3 right here. Stuff on the outside was fine. So I'm thinking this will be a vertical stretch of 2. So let's double check. So down, I'm going to clear this out. Let's go 2 alpha trace y1 and graph that. Yes! It's a vertical stretch. So this one moved up to 2. Yep, vertical stretch. So this one is a vertical stretch of 2, just like I thought. Vertical stretch of 2. Equation, y equals 2 absolute value of x, because this was on the outside of the y, wasn't in the parentheses, which means that this is 2 times my original function, absolute value of x. So I think my next one's a vertical compression. I think so much that I'm going to go ahead and start writing it. Vertical compression of 1/2. And let's go ahead and double check that. So y equals, I'm going to come down and I'm going to do with the 1/2. So I'm going to alpha y equals, so 1 over 2. I have to delete this and graph. Yes! It is a compression. So now this 1 has been bumped down to 1/2. And we are good to go. So vertical compression of 1/2, which means it is y equals 1/2 absolute value of x. Function notation f 1/2 f of x. Okay, so I want to kind of sum everything up. Everything on the outside is going to be a vertical transformation. It's vertical, it's going to affect y values. So that means that if I have a minus out here, it will affect my y values, so it'll reflect over x-axis. This A will be your vertical stretch or compression. Of A. So if this is a 2, it's a stretch of 2. If this is 1/2, it's a compression of 1/2. We don't have to mess around with it any. This is a vertical shift. Now on the inside, this is everything that has to do with x, which is going to be opposite. So if this is a minus, it's actually the opposite sign. So this is going to be our horizontal shift. This is going to be our horizontal stretch and compression. And then on the stretch and compression, we flip it. So if it's B, it's actually a 1 over B. Or if it's a 1 over B, we flip it to be B. And then if it's a negative in here, it is a reflect over Y, because it's going to change our x values. Reflect. I didn't leave enough room, did I? Over Y. Okay, so we're going to go through and we're going to practice going through these. So name the parent function, write the function notation, and describe our transformation. So this is definitely absolute value, which is y equals absolute value of x. Now this is on the inside, so that means that this is f of x minus 3. By that, since it's on the inside, it's a horizontal, and it's going to be a shift. So horizontal shift of positive 3, because remember we changed the sign on the inside. So that means it's just my absolute value graph that's been moved to the right 3. Okay, so let's look at our next one. This is definitely a quadratic. Y equals x squared. And then we have the plus 6 at the end. So that means that my function has just been added 6 at the end, which means it's a vertical shift of 6, or up 6. So in our next one, this is definitely a square root. And on the inside, I have an x plus 5, so this is my function at x plus 5. Now because it's on the inside, it's going to be horizontal shift. And then on the inside, it changed. So if this is plus 5, this is going to be negative 5. Okay, so next one, a little bit more complicated. There's some more stuff to it. So this is still square root. Now on the inside I have a negative and on the outside I have a plus 4. So this is f of negative x plus 4. Now the inside changes my x values. So that means it's flipping across y. So reflect over y. And the plus 4 at the end is a up 4 or vertical shift of 4. And so once we know these, it makes it easy for us to go back and graph. And we've been graphing, so that should be no big new thing for us. So next one, this is definitely a cubic. And it looks like our function, we have a 2 on the outside and an x minus 6 on the inside. Now the 2 on the outside is a vertical stretch. of 2. And then on the inside, the negative 6 is really a positive, and inside is horizontal. So this is a horizontal shift of 6. Okay, so our next one looks like a line, because it's x to the first power, so it's linear. Looks like I just have a minus 8 at the end, so this is f of x minus 8. And so that means, because it's on the outside, that it is a vertical shift. Shift because it's plus or minus of negative 8. So then our next one, it's definitely a square root. Inside we have 2x, so this is f of 2x. So that means this is going to be horizontal because it's on the inside. And since it's multiplication, it's stretch or compression. And we do opposite inside. So this is a horizontal compression, because opposite. And 2, when I flip it, becomes 1/2. So this is a horizontal compression of 1/2. Okay, looking a little, we're almost there. Need a new color. Well, I guess we'll just go with brown. I don't know. Here we go. Let's see. Outside is vertical. Oh, this is absolute value. Let's start there. Absolute value. Outside vertical, it's multiplication. So this is a vertical compression. Of 2/3. Let's see, inside I have plus 6, so this is inside is horizontal. This is a plus, so it's a shift. But it's opposite, negative 6. Now my function, which I forgot to do, 2/3 on the outside, f x plus 6 on the inside. So it's really not as bad as it seems. I'm going through a lot of stuff because I really want you to make the connections. I want you to have lots of examples to help you. So we're almost done here. Yay! And so now we're just going to go ahead and apply this to some graphs. Graph our function, so our original function's on there, of x minus 2 plus 3. So what's this mean? Well, this means it's horizontal, positive 2, so that means I'm going to go right 2. This is vertical because it's on the outside. Doesn't change if it's on the outside, so this is up 3. So I'm going to take every point and I'm going to go right 2, up 3. So right 2, up 1, 2, 3. So that point goes there. That'll keep going across. So here I'm going to go right 2, up 1, 2, 3. So now that'll connect down. From here, right 2, up 1, 2, 3. And then from here, right 2, up 1, 2, 3. And then this goes straight across. So now I've just transformed my graph. So now let's look at the next one. So my negative is on the outside, so it changes the y value, the sign of my y values. So I could look at this and, okay, if this is a positive 6, this should flip down to negative 6. There we go. I just reflected over the x-axis. Okay, so this one, well, it's on the x, so it stays the same. I reflect over the x, I change the sign. There we go. I reflect, so I change the sign. And there's our new graph. So this was a reflect over x, and that just helped me graph it. Okay, next one, f of 1/2 x. So this is inside, so it's horizontal. It's timesing, so it's a stretch or compression, and because it's inside, I flip it. So this is going to be horizontal stretch of 2. So I'm going to take each point, I'm going to times by 2 on the x value. So this x value is negative 4, so I times by 2, it now becomes negative 8. So there's that part. Okay, this times is by 2. Negative 2 becomes negative 4. So now there's that part. Okay, this 0 times this by 2 becomes 0. So we're seeing now how we're stretching this out towards the side. Okay, this x value is 2. If I times by 2, I get 4. And then this will just stretch out that way. Nice thing about the flat line. So you can see that we've been stretching it out this direction. And honestly, I think those horizontal ones are kind of the hardest. Okay, so last set of problems and we are done. Yay! Given that our original function is negative x plus 4, we're going to transform this, we're going to pretend this is my parent function, by a vertical stretch of 1/2. So if it's a vertical stretch of 1/2, that means I'm timesing on the outside, because it's vertical, by 1/2. So I'm going to do 1/2 my function of x. So what does that mean for my actual equation? Well, that means I'm going to do 1/2 times the entire equation. And this is going to be my new function. We're going to call this new function g of x. So I used this to help me write my new function, which means my final g of x will look like, well, I have to distribute this 1/2 times negative x, negative 1/2 x. 1/2 times 2 is 1, and there's my new equation. So now I have transformed it. This will help me graph the new equation. Okay, so next one. Given f of x equals 3x, move it left 6, and the vertical stretch by a factor of 4. So let's see. We're going to call this g of x again. And I'm going to move it left 6. So that means, and the vertical stretch by a factor of 4. Okay, vertical goes on the outside, so I start with that. Vertical stretch by a factor of 4. So there's a times by 4 on the outside of my function. And then on the inside, I'm going to move it left 6. So that's negative side, which means I write it as the opposite, which is positive. So this is vertical stretch of 4, and this is moved left 6. So now that's what I'm going to do to my graph. I'm going to go ahead, I'm going to do 4 times 3, but then in the x spot, I'm going to put x plus 6. So now all I have to do is start from the inside and work my way out. So I'm going to distribute this. So now I get 4 times 3x plus 18. And then I distribute this. So now my new g of x would be 12x plus 40 plus 32, 72. And there's my equation. So again, lots of this type of stuff. We're going to be practicing with it. And I think you guys are doing great. So I can't wait to see you in class.